I hope that you are ready to listen for a very nice talk, invited talk by Stefano. Let me first introduce Stefano a bit. So if you are using a MacBook Pro, probably you are using the binary version of R. That is thanks to Stefano, as he is one of the people that are taking care about binary version for our OS. Also, if you are considering publication in JSS, you should know that Stefano is an associate editor of JSS, so you might ask him about something about JSS, not only. And also, he has a lot of contribution in bioconductor. So another thing. Yet today he will talk about something else. He will talk about sentiment analysis, social media, and big data. 3 very hot topics. So yeah, let's welcome him.
So thank you very much. Of course, I need to thank the organizer of this conference and all the participants of this conference, which makes R great every day. So I will talk about sentiment analysis and social media. So how to my understanding, is the better way to do this. And of course, this is related to big data. I was a former R-Core member team, as Martin explained in his talk, and now I'm an undeserved member of the R Foundation, so I'm still keeping spreading the word about R. So let me give you my quick R-Core moment about R. So this was my contribution to DSC 2001, 17 years ago, where Martin and others invited me to this conference in Vienna. This was the second event. And I remember I started trying to build R myself in August 99. So I spent all my summer in 99 to try to figure out what R was. I needed a software, and I had a Mac, an old Mac, and no way to build C or Fortran code on a Mac at that time. So this was the first user interface on the Mac. And finally, at this conference, I presented very proudly the compilation of these 20 packages, which were available at that time on the R, say, C-Run, incarnation of C-Run. Now we have 15,000 and so forth. And finally, at some point, we got the first GUI on the Macintosh. This was called the carbon-based layer from the old Mac to the new transitional, say, up to come out macOS 10 version. Now we have the macOS 10 version of R, which is continuously supported by Simon Urbanek, which is still in R-Core. So that's all for my R-Core moment about R. So this is the claim of this talk, which is in the abstract. So despite the huge development of automatic methods, I mean unsupervised method, or NLP, natural language processing, or ontology-based algorithm, social media data are not as easy to analyze as one might think. Compare, for example, to the analysis of, say, romance or other digital text. And the reason being that the creativity of humans and the continuous change of online language make all these methods to fail to my best knowledge. Of course, I teach this method to my students as a statistician, so they work very good, very finely when you work on a very, say, well-defined domain. But social media is quite different. So my suggestion today is to use supervised method, which means part of this text must be human supervised. So part of the analysis must be human supervised and should be very topic specific. So general methods, I discourage the use. So let me start from the origin. So a long time ago in a galaxy far, far away. So this is the Star Wars initial screen. Because not all of you are experts in sentiment analysis, most of you on big data for sure. But let me give you an overview of why I think this approach, so the standard approach, is not working. So what is data science? Data science, it's a mix. This is a buzzword, but it's a mix of statistics, computer science, but also field knowledge. So this field knowledge is the key of my talk. And I mean, when you try to analyze sentiment, and by sentiment I don't mean positive or negative, I mean opinion expressed on the social media or any digital text, you need to know what you are doing. So just using standard machine learning or standard NLP rules or ontologies doesn't work. And so we know data scientist is the sexiest job of the 21st century. This was 2010 when it was first published on The Economist. So this is the cover page of The Economist. But it starts much more long time ago. So it starts like 3000 BC, when this population needs to actually count military force, count how to apply taxes to the inhabitants. And for example, in the Bible, you can see at some point Moses and Aaron, in Exodus, they try to count the population and the enemy force to organize the movement of the Jewish people and so forth. So it's a long tradition. And then at some point, more recently, becomes two things. So analyse de données was introduced as a team by Ben Zekri and his colleagues in 1916 in France, and then Gauss was the modern statistician, in the sense that he started thinking about models. And these are two different strands, you know very well. One is more about explorative data analysis, where part of data science is, and I think sentiment analysis is also part of this. And the other one is about, I have a model, I have data, I want to fit the data to this model. So the model is the most important thing. So by definition, most of machine learning and statistical models, they are models. So you assume that something comes from the model, so population is generated, so data are generated from some population and so forth, and you want to apply this model to the data. So the point is that when you try to do this on social media data, the population is not defined. And even if you think of the population as the text you want to analyze, this text may belong to different types of populations. So as soon as you put a model on the text analysis, the result of the analysis will be the model itself. So you don't get any real insight from the data if you just start from the model. So I think data science at present is more on this side, but of course we need the link between the two. What about computer science? This is just for fun. It is as old almost as statistics. So the first analog binary computer is called used by Ray to calculate precise timing of eclipses, dates about 200 BC. So it's a long history, our discipline. And then finally, Turing in the 90s introduced the concept of modern computer science, machine learning, artificial intelligence, cryptography, and so forth. So that's one of the reasons why we are here. So everything worked very nicely since, say, early 2000. But at some point, something went wrong. And it went wrong with the data. So data became unstructured, so no reference model. Of course, we can tidy data, so we can clean data, we can prepare data for the analysis, but data itself, they come from something which was not prepared for the analysis at first time. And they began many, so we talk about big data. And this was due to the technological progress in many disciplines, including, for example, of course, internet applications, biology, bioconductor was mentioned before. You know, biodata can be very big, too many variables, too few observations. Physics, say HLC experiments, or finance, high-frequency finance, and administration. So many administrative data are now available through, say, as open data or even administrative data, which can be analyzed later. Okay. But there was a missing part in this history, and the missing part was statistics. So I think you are familiar with this 3V, say, story, which was introduced a few years ago. The 3V were volume, velocity, and variety. So what are they? They are just a way to, say, collect the data, organize the data into databases, and sell it. So it's essentially the way vendors of systems So the database systems or, say, cloud structures, they want to sell you the capability of analyzing big data, but statistics was completely missing. So this was 2016 till, and it was the history about velocity, volume, and variety. But very recently, IBM introduced these slides, and I'm very happy. And there is a fourth V now coming up, which is veracity. So what this data actually convey, what is the uncertainty in the data. And so this is the basic concept of statistics. It's not just about the data, how to store them, how to query my database, how to link database. It's also what do they convey as information. Okay, so that's a long introduction. And I just want to show the last slide about this. So 95% of the company, this is from Forrester, very recent report. They think data science is important discipline to develop, but only 25% of companies seeing significant business value from it. So it means that data analysis on big data without any insight is useless. And it's still the sentiment, so to say, I perceive when I work with company and I talk about data science. So again, the point is not just using techniques, not just using the data, but try to extract information from this data. So meanwhile, this was last year cover page of The Economist. They also understand, so even economists understand there is value in the data. Normally, they just do model. I mean, I work in the Department of Economics. I know there are many people from economics here, but they just believe in their models. Okay, then data must oblige the model to satisfy their theory. So anyway, this is my final, say, quote about data and big data and so forth. I like this quote from Areli from 2013, which says, big data is like teenage sex. Everyone talks about it, including me. Nobody really knows how to do it. Everyone thinks everyone else is doing it. So everyone claims they are doing it. And this is more or less the truth today yet. Okay. Of course, you're not such person, I know. So before going into the analysis, so how I think sentiment analysis should be done, I want to impress you, say, with some examples. So this is just the outcome of the analysis. Of course, you know, penetration of internet is now essentially almost all the population present in the world. So 50% of the people are connected and they are in urbanized, say, location. And most of them access, so 5 billion people access data or internet through the mobile, which means essentially everyone is connected in a way or another in a social network. Okay. I don't want to bother you with what you can do with Twitter data. Of course, you know, part of the data are geolocalized. The same is for Instagram, but now Instagram has closed API, so which makes things a bit more difficult. But you can buy this data. And you can do things like this. You can follow people during their daily life. You can also see how people concentrate during events. So you can use to monitor, say, movement of population. And this is another application where we follow the, say, all Twitter accounts from Italy and where they did travel in the last 4 years. So you can track. And they actually correlate quite well with the real actual air traffic from Italy. But you can also attach sentiment on geolocalized regions. So, for example, this is an analysis we do every day in Italy. It is called HiHappy. It's a simple, silly index of happiness of Italian, say, Twitter accounts. And you can build map. And this is using ISA, which is the sentiment analysis with algorithm, which I will talk very shortly. And we did the same in Japan. We call iGenki because Genki the sky is how do you feel today in Japanese. And this is just an application of what? So we know social media data are not representative, but the signal conveys some information. So for example, during the Kumamoto earthquake 2 years ago, so yellow means, say, happy, red means, say, sad or fear or unhappy. And you see in the region around Kumamoto, which is the lowest island in Japan, it becomes very red. And then you see in the other region, say very far in the northeast part of Japan, after a few days, the situation becomes normal. So the sentiment is constantly, say, half positive. But then around the region of the earthquake, still some, say fear or, say, negative sentiment remains. So this means that you can track and geolocalize these signals and maybe understand something about what is happening in real time. Okay, but this is just the outcome of the analysis. So why I insist on this, so field expertise is a must when you do sentiment analysis. Because that one was essentially blind. So apart from using Japanese instead of Italian, you can actually do this with the NLP or using some dictionaries to say this sentence is positive, this sentence is negative. But when you want to go a bit deeper in analysis, you mean to understand what you're doing. So let me show you an analysis we have done at the University of Milan about these people. So the research question, there were two research questions. One was how strong is the online support for ISIS on Twitter and other social media, but this analysis is only for Twitter. And what is the relationship between the online support and the number of foreign fighters? So people who move from, say, Western countries to fight for ISIS in ISIS territory. So we did this analysis for The Guardian, and this was the map we produced in 2014. What you see here is the relative support, which means, say, positive support towards negative support, by excluding all the neutral comments on Twitter. And you see, no, you don't see because I can't see. Anyway, this yellow dot in the center of Europe is 31%, and this is Belgium. So what does it mean, this number? It means that compared to the other region of Central Europe, the online support, so the expressed online support for ISIS, was 31%. So excluded, so the neutral part. So of course, not 30% of the people on Twitter on Belgium, they are pro-ISIS, but just those who comment something. And then you see other situations, like in Qatar, it was 47%, Pakistan is very high, and as long as you move away from the region, so Syria is even 7.6, so it's very small support. As long as you go away, you see this support normally increases. And so you can explain this by, say, political science or, say, terrorism studies approach. So in Qatar is one of the highest supporter of ISIS. The same is for Pakistan. In Syria, they don't talk much positively about ISIS because they are very close to the caliphate, and because Syrian country government actually control that you don't tweet too much toward, say, terrorism. Say ISIS, not terrorism, and so forth. But then, as you go far, this kind of, say, ISIS support becomes more like, let's say, a romantic view about ISIS, about they are trying to keep Islam great again, and so forth. Anyway, we knew that in 2016 we had the first large attack in Belgium, and this was quite scary. And so we tried to analyze this in time from 2013 until to, say, last year. So according to different studies, we saw, by using different methods, that the average support online is 25% of the tweets. 1/4 is the baseline. So normally people, they did talk, now it's no longer the case, about, say, 1/4 people, they talk positively about this. So this is the baseline of analysis. So now taking these two simple indicators, which we call sentiment deviation, so how far we are from the 25% baseline, and how is the daily variation about the average number of tweets, which was, the baseline was 128,000, what we can learn from this data. So this is the deviation from the 25% threshold, and you see that when they win, so when ISIS had military victories, we have some peaks, positive. The beheading of James Foley, the first, say, Western people which was beheaded, they just decreased a bit. The support was ISIS on the On the internet, when the mosques have been attacked or they lose some battles, the sentiment goes down. And when they beheaded the Lebanese army soldier, it goes very far down. So what does it mean? This that maybe this data convey another information. So people talking about ISIS are not concerned about Western versus, say Islamic country. They are just concerned about Islam itself. Okay, and I will show you this later. What about the volume? So the news becomes important only for when you kill someone from the same, say, religion, and no effect essentially for the other cases. Or when you have the defeat, or when the caliph is injured, or after or around Charlie Hebdo events. Okay. So I skipped completely the statistical analysis, but I just want to show you this map. So this is the average 20.8 was the average support in France. And during the day of the attack at Charlie Hebdo, which was 7-8 January, the support goes down to 3%. But 2 weeks later, or the next week, it goes up to 17% again. So it means that people stop talking about ISIS at that moment and then start again. And this is what we call the short memory effect of this data, social media data. So people just switch the attention to something else, and then the average threshold comes up again. Okay, so the second point was about foreign fighters. We try to correlate the number of foreign fighters. There is a time series for this type of information. So we try to correlate this. And what we see in this graph is that as long as the Twitter sentiment is low, the number of foreign fighters is very high. As soon as the express sentiment toward ISIS grows, then you see if the sentiment grows from 10 to 20%, so it doubles, the number of foreign fighters actually halves, which means something from, say, political analysis. And this something is that if you allow people to express their frustration, say their support toward ISIS and so forth, they don't need to exercise the negative part of this. So going as a foreign fighter, and so if you leave these people talk, they are unlikely to radicalize compared when you try to stop this communication signal. And so we published this on the Washington Post, this analysis explaining why shutting down the Islamic State on Twitter might actually help to recruit people. And this was later proved by some on-field analysis, because because they just changed social network. So shutting down the account Twitter is not a good way to do. So it's better to have them talking on the internet so we can track them instead of allowing them to create other things. So I have one more thing about this story. And I introduced this before. So what was the main point about the discussion? So you see here on the upper part you have the main reason for people supporting ISIS, and on the lower part the main reason for people, say, unsupporting or have negative sentiment about ISIS. And if you see this plot, you see that the highest percentage, say, of opinions were about defending Islam. So ISIS is good because it defends Islam. And the negative one was they use religion for political aims. But if you look at all these items, essentially no one talks about Western countries. They don't care about West. They care. It's just an internal discussion about whether ISIS is really the key for Islam or not. It's a completely different perception from what we have about ISIS. Okay, that's the first point. Second point, how to extract this using NLP or using ontologies. In which dictionary will you find this kind of information? Essentially no one. You can use any R package, any libraries you want. This was Arabic, by the way, and you can't find this. So the only way to extract this information is to do supervised analysis, like qualitative analysis at the first glance, to try to understand what people are really talking about, not just using positive and negative, say, dictionaries to understand sentiment. So that's the reason why I'm showing you this. And again, this is about looking at the data rather than just using models. Okay, there is one more thing, part 2. So we try to correlate to other things, because another hypothesis was that the duty not paid for cigarettes and liquors and alcohol and so forth is used to finance actually local ISIS activity. And by using some, say, technique inherited by finance, which is called lead lag analysis, sorry, we try to correlate the sentiment and the amount of duty not paid, which is a time series collected by vendors of cigarettes. And we see there is some correlation between the percentage of DNP in France, for example, and the number of foreign fighters, but we also see some say, anticipative effect. So we see that DNP grows at some point, and say time T1, also the number of foreign fighters and the support toward ISIS on Twitter also grows. And then later, at time T2, T is here, T1, T2 are quarters, okay? This is the frequency of this data for DNP. And then we see then some actions follows later. So you can do this kind of things, which is much more than sentiment analysis, by trying to use some more sophisticated model. Okay. And quoting my favorite quote from Bill Gates, 64K ought to be enough for anybody. Enough. So enough about examples. Now let's go to the main point of the talk. So I like to quote Gary King, so many quotes in my talk, which says the best technology is human-empowered and computer-assisted. So computers should help us, and say algorithms should help us, but the main brain should be left in our head. Okay, so there are different ways of doing text analysis, and this is kind of a taxonomy you will find in many, say, books. So you can either score the text or you can classify the text, do analysis on the text. And when you classify the text, you can do, say, topic discovery, so all the topic modeling approach or clustering and this kind of techniques. Or if you know topics, so I'm talking about, I'm going to do an analysis about ISIS, so I need to have some information about this, which I can use for my analysis. Then you can use ontology. Of course, you can use ontology in many cases, or you can use supervised method. So you don't leave anything to the model. You use your knowledge and try to have the data teach you the point. And then you can have individual classification, which is the typical machine learning approach. So I train my data, and I have a train set, and I want to classify through any of these models the test set. And for each individual entry in the text set, you do the classification, or you can do what we call aggregated distribution, which is typical in social sciences, which means instead of willing to know whether this text is positive or negative, I want to know whether on my population of text there is some percentage of negative, positive, and so forth. So it's about estimating directly the final distribution rather than in individual classification. Of course, these are related, but this is kind of taxonomy which I think clarifies what I'm talking about now. So we are in this red circle. Okay, so I don't know if you ever use unsupervised or automatic sentiment methods. The reason why they fail is that 90% of the time they produce a neutral score, so a neutral sentiment. And the reason why is that those dictionaries or those rules are not tailored for all types of text. So they are tailored for very specific, say, corpora. And so this 90% is just, I don't know how to classify this text, so I assign neutral score. Then you look at the data and you discover, oh, no, it's not neutral. They are actually saying something. And they even express opinion about something. So think about a quote like this. This is a real quote in analysis of the third iPad that we analyzed, the launch of the third iPad. So I like iPad because it has a large screen, but I won't buy it as it is too expensive. So half is positive, half is negative, but in which sense? So if you consider price, then it's too expensive, you can classify as negative. If you think about, do you like iPad or not? Yes, I like iPad. But then you also have information about why do you like iPad. I like iPad because it has a large screen. Okay, so you have 4 information there: whether you like or not the product, why you like it, will you buy it, and why you don't buy it. Okay, we have 4 types of information which you cannot resolve by using dictionaries. Other more more basic, again, you can't read anything. So think about the sentence, what a nice ripoff. So the very elementary dictionary approach is, okay, I have a positive term, which is nice, a ripoff, which is negative. And so if I'm a human, I completely understand that this is a negative sentiment about something. But if I'm an algorithm, then there is probability of 50% of misclassification. And then you can say, okay, but I use NLP, so I introduce semantic rules. So whenever I see nice and ripoff together, I say this is negative. So you have to introduce manually some rules, which actually corresponds to reading this text and classify manually. Okay, so you just move the problem to somewhere else. But then, do they work or not? These rules? No, they don't work because the language actually evolves continuously. So people, they use metaphoric sentences, and out of the blue, they can start talking about something which is not related to the topic. So this is, for example, an example from the second debate, from Romney and Obama second debate, presidential election campaign. What Obama says is a quote about horses and bayonets. So at some point, Romney said, you cut the expenses for the chivalry of the army, of the Marines, and Obama answered, do you think we are still using, so our army is still using horses and bayonets? Of course, this is kind of a rhetoric sentence, and also it tries to, to make Romney in a bad situation, and in fact, Romney actually lost this debate. But the point is, this horses and bayonets sentence became a trending topic in the next days of the campaign. So this ushered, and also the topic becomes trending. Actually, Romney's was correct. So the army, the American U.S. Army, still uses horses and bayonets, and actually Obama cut the expenses for the army, but no dictionary will contain this kind of sentences, because this is not, by any definition of ontology in political science, is not related to any political debate. So it was just introduced by Obama out of the blue. So that's the point of, if you want to introduce NLP rules, you have to introduce as much as any text you see on the social media, which is completely different if you analyze romance or, say, transcription from bank activities, which are very well defined. Okay, a few more examples, and then I stop. The first one is from a DB movie review. It was about, it's a review about a movie, which says this movie has a good premises, looks like it has a nice plot, an exceptional cast, first-class actors, and Stallone gives his best, but it sucks. So 5 positive, 1 negative, and even if I count the number of terms and so forth, then I get the wrong information. Moreover, this "but it sucks" comes after the comma. If you ever did a text analysis, the first thing which you drop in the analysis are commas, point, stop words, and so forth. So you don't see it. Then the Latin sentence, for those of you who did study Latin, this is mainly for Italian, this slide. So anyway, so this is from the from Latin, ibis rebis, dedibis nuncam peribis in bello. You see this sentence has no commas, has no punctuation, but if you introduce punctuation, it changes completely the meaning. So in English will be, you will go, you will come back, you will not die in war. Or if you move the comma elsewhere, you will have, for the same sentence, you will go, you will not come back, you will die in war. So completely different meaning. So who can give the answer to the interpretation of this sentence? Only the human. So only if you have cultural references, you can actually understand what this bag of words actually is saying. The third one is for Italian people only. It's a joke. And the last one, you can understand. So there is no favorable wind for the mariner who doesn't know where to go. This is a famous metaphoric sentence from Seneca. And it was actually a tweet against our former prime minister. So it's completely unrelated to the sea, the fishing, and the wind. But it was something about the political debate going on at that time. Okay. So I think I conveyed the idea. And now at this point, you can say, okay, you are crazy. So you're here and you say that we don't have to use ontologies or NLP. And they consist in 95% of the research. So if you look at all the paper about sentiment analysis, 95% are about this. No, I'm not crazy. So they work. This methodology works, and I teach to my students, I told you, but only when there is no misspecification in the data. So if you analyze, say, parliamentary speech, official documents, court rulings, poems, scientific literature, and so forth, you can actually use NLP. They work very, very nicely because there is no misspecification in the data. But otherwise, you have all the sort of problems we have seen before. Okay. So if you agree with me, so just let me explain how this works in practice. So how we can switch from words to some algorithm in the common practice. Say. So of course you have some text. You divided because it's a supervised analysis in training set and test set. The human classification, the classification, the training set is done by the human. So you don't use ontologies, you don't use dictionaries, and then the rest is done by the machine. And what you do, as I told you before, you decompose this text into, say, stems, so which means the root of the words. You drop all the stop words, commas, and so forth, conjunctions, and so forth, and you're left with some bag of words. So you even lose the order of words. This is completely unessential to the point. And you come up with a matrix like this. It's a matrix of 0, 1. You count present or absence in each of these sentences of the words that you have, say, selected for the analysis. Sometimes you can also add the frequency of the word. So let's say nuclear in the first text appears 2 times. You can use 2, but this is still unessential. So the main point is in the bag of words approach is that you just count the presence of or absence. And then you want to, the category DI, is how you want to classify this test. So I'm in favor about nuclear energy in Italy. This was an analysis about nuclear energy in Italy. So I'm in favor, against, and so forth. So this is the first step. So you have the vector of stems or features, like we call in machine learning, and DI is just the dependent variable in the model. And the first thing you see that in opinion, these are not aligned along any axis. So I can be in favor. I can say, okay, I can stand with it, but I fear it. I'm against, but it's economic, so I can take it. Okay. So there is no linear underlying way of thinking of humans. So opinions normally follow this type of structure. Okay. So now think about the Italian dictionary or the Oxford dictionary. You have 5,000 different terms in the dictionary. And now think about each of these rows. So in principle, the potential matrix or the model matrix might be something like 5,000 rows full of 0 and 1. So it's a very sparse matrix, very big. And then you have the number of rows, which are the text. What happens normally that even though you have this high number of words, in practical discussion, you use a very few number of words which are meaningful. And normally this amounts to, say, 200 or 500 words. So the dimensionality reduction is really done by the fact that we use some words instead of other words. But still, statistically, from the statistical point of view, the number of possible combinations, so the number of possible, say, X vector that you can see in your data is something like 2 to the power L, where L is the number of stems. So if you have 200 stems, just 200 words, with these 200 words, you can actually build up like 1.6 times 10 to the power 50 different sentences. Okay? Of different zeros and one. Okay, so the usual approach is like this. So I want to classify D, in my opinion, and I have a set of features, words, 0, 1. Normally, any machine learning or any statistical model do the following. I'm looking for the probability or the frequency that I see, for example, positive, so D equal positive, given this set of words. It's like in regression analysis. I want to predict Y given X. Okay, X are my regressor, and Y is my dependent variable. But it's a probability because we are trying actually to estimate some proportion of something. And then you weight by the number of times you see this in your data. So P of S is just the tabulation of how many times you see these rows. The problem is that this P of D given S is impossible to estimate in any real application. So by PD given S, you can replace any of these guys, so support vector machine, random forest, DNN, deep learning, whatever you like. So all statistical methods are like this. The problem is that they produce very high variability, you will see, and they also introduce bias in the estimate. The reason is that, statistically speaking, the denominator, when you try to estimate an empirical frequency, you have a numerator and denominator, okay? So the denominator is like 2 to the power L. This is the number of possible cases you have in your data. And the numerator is just what you observe. It can be a few sentences, okay? So this ratio is most of the time 0. So you estimate this probability as 0 most of the time. And this doesn't work, of course, because the most relevant category in social media data are usually the noise. So noisy data, social media are noisy data. So most of the time you have noise. And so the highest probability in this model will be assigned to the noise label. And so when you try to use this model to predict, the prediction will be with high probability. Okay, my data is noise. This is because this is what the model sees. This is because this is the main idea of statistics. Okay, but you can do the other way around. So this is an idea of Hopkins and King paper. Instead of using this conditional probability formula, you use the reverse one. And this second one you can estimate very easily. So this PS given D is the reverse probability. It's like you want to estimate the regression by starting, instead of Y given X, you start from X given Y. You really reverse the statistical problem. And so P of S is given by PS given D times PD. This is from probability law. And you can see this as a, say, regression model, but where X and Y have been exchanged. And so there is some solution, which we know from statistics, by just, say, changing the name of the quantities. So if I want to estimate PD, so my beta, I just do the reverse, generalize the inverse of these matrices and get the estimate of beta. There are only two problems. One is that PS given D is still a sparse matrix. And so you need to work on sparse matrices. And also, beta must be positive and should sum up to 1. So you need to use some kind of regression, so least squares approach to solve the problem, but you can solve it. So what does it mean P of S given D? Instead of focusing on the probability that this sequence of words predict me positive or negative, I do the reverse. So I focus only on the text for which, for example, I manually classify them as negative, and then I see which words actually supports negative. Okay, it's really the reverse. So the number of text now is much lower because, for example, I coded, say, 50 text using only which gave the outcome as negative, and so I know which words have been supported by this negative sentence. Okay. So finally, the second probability is much easier to estimate, and the accuracy is much higher. I've run out of time. But, so by using this approach, you can see that compared to other standard techniques, you see there on this table, DNN or so deep learning and convolutional neural network, you can see that to obtain the same level of bias, so low bias in the estimation, for using this reverse approach, you can actually need very few text, like 250 human-trained text, while if you want to use deep learning to get the same, or sub-vector machine, to get the same precision in the estimate, you need to go 20 times upper. Of course, if you are Google and you want to classify images, of course you have all the images and they are all tagged. But in any real analysis, you need to do manually classification. So in this case, you can be very efficient in terms of how many texts you need to classify by solving the inverse problem. You see the bias is essentially 0, so there is no variability and no bias. And also computationally efficient. This is the log scale in the y-axis. If you increase the size of the data, with this technology, so by using the inverse probability, the execution time remains constant, while for all the other methods, of course, for this model to converge, you need to wait an exponentially large time. Okay. And by fast, I mean like this. So 2 seconds for this technology, and like 900 seconds for random forest, or 5,000 for sub-vector machine. So on the same data, on the same training data, and all the rest. I think I'm out of time. I just want to say that there is an R package which does this. It's very efficient and so forth. There are no for loops. So I didn't talk about the content itself. It's just 200 of R code. There is no C code, and it's blazing fast, like you see. Even if you analyze billions of data, once you have done the stemming, and this is done by Quanteda or other packages, and then you want to classify, it takes 2 seconds to get the result. And the trick is really simple. Just I want to show this trick. So instead of working on this 6,000, of course, no question at the end, but I just want to show it. This is really an R trick. So instead of working on 0, 1, 0, 1 columns, you collapse this into a string, just one string. So instead of working with 600,000 variables, you work with one variable, which is a string. So you can treat it as a factor, and then you can further, because you know you are a geek, so you know 0, 1, 0, 1 can be transformed into the hexadecimal. You can shrink by 1/4 the length of the string, and then you can do the analysis very fastly by simple tabulation and solving some simple inverse problem, say regression problem with constraints. Okay, that's it. Sorry.
So first, please do not leave this room. We'll have few words from organizers. But before that, we have time for one question. So who is going to ask the question? I have one, actually. So you said that we should do these things differently. Which book would you recommend for someone who is going to do this in the right way? Is there one book or article that should be, the must know?
There are papers, but all the books start from machine learning, so they start the other way around. I'm sorry, 95% of the literature now is about this. So we are writing a book, but there are papers. So you should start from Gary King's paper, which is the first paper which tries to switch the problem by introducing the inverse problem. And then from that, you follow the literature, the stream of lecture. So read me is the key. It's the name of the paper.
He's writing the book, Thank you very much.
Thank you.